Maintenance management is a combination of any action carried out to retain an item in or restore it into an acceptable condition. This is usually one of the purpose of the maintenance management, to keep our equipments, production equipments, or if we expand the horizon to the physical assets of any organization, to fit for the use. In case of the production or manufacturing, if the equipment is down, then we get the less time to produce anything. That means the downtime is deducted from the actual available time. That reduces the total available time, and consequently the production or productivity of that organization, that also gets reduced. This is one of the purpose of this maintenance management. Another is that it keeps the entire production systems more reliable, productive and efficient. Now, what are the objectives of the maintenance management? To maximize the availability and reliability of all assets. Now, this availability and reliability, these two terms have been coined from the military establishments. Military is always available, military equipment should always be available for the operations. That we call the availability. The maximum time it is available, we try to maximize these things, and reliability is defined in a certainly different way, that probability how long this equipment or components will work under specified conditions, that we call the reliability. So maximum value of the reliability, it can be the 1, that is the 100% of the time it is available for that, or 100% of the probability can maximum be 1. So it is one kind of the calculation of the probability, that we call the reliability. Reliability has a connection with the failure rate also. So 1 minus failure rate, that we call the reliability. To second objective, to extend the useful life of an asset by minimizing wear and tear of the deterioration. We try to maximize the operating life or useful life of any equipments or components through maintenance, by minimizing wear and tear and deterioration, so that it can work for the longer period. Third objectives, to ensure operational readiness of all equipment required for emergency use at all times. And fourth, to increase the equipment utilization by reducing downtime. This third objective is more prominent for any kinds of defense activity, whether it is the Army, Navy and Air Force. And fourth objective is more important for the manufacturing organizations. So how this course and how this theory of the maintenance management has developed over the period of the last, say, 60 years. Usually maintenance is considered always a firefighting approach. After the Second World War, gradually it has developed into a theory and organized activity in most of the large organizations in Western countries. And we have also adopted in India, many organizations are adopting this theory into practice. So let us see how this theory has been evolved over a period of time. In 1950s, we have given more importance the preventive maintenance, because we know the one English sentence that prevention is better than the cure. All immunization for the human body, it is done to prevent the occurrence of any disease, and same theory has been applied in the post Second World War for the equipment and components in the manufacturing organizations. So in 50s we have first developed this preventive maintenance concept in 1951. Then we have another concept, productive maintenance, 1954, and maintainability improvement, that we have developed in 1957. This maintainability means that if the equipment goes out of order, in that case how much time it will require to restore these things, how quickly we can repair the equipments, that we call this maintainability of the improvement. Of course, the reliability of the components, reliability of the equipments, those are all interlinked phenomena, but we have seen from that aspect, because the design of the equipment cannot be changed after the equipment is manufactured. So this approach, this indirectly incorporate the design of the equipments for the purpose of the maintainability in the theory. So that we call this maintainability improvement. It has developed way back in 1957. Then in 1960s, we have this productive maintenance related with the reliability, efficiency and plant design. Because as just now we have mentioned that how quickly the equipment can be restored, it depends upon how it has been designed and how quickly the spare parts of the equipments can be available in that. So plant design is also an important factor for the productive maintenance. So this concept is more ingrained in the 1960s. So we call at that time maintenance prevention, reliability and maintainability engineering in 1962. We have another concept has developed in the mid 60s, that is we call the engineering economy. So when to replace that deals with when to replace the equipment. What is the operating cost of the equipment? So cost has been taken in that way, that what is the original cost of the equipment, what is the operating cost, what is the life period, what will be the salvage value. So all these things has dealt with, the decision has to be taken on that basis, that we call the engineering economy. And in 1970s, we have the total productive maintenance systems. It is the system based approach. System means considering all the components of the overall area of the maintenance and of the equipment. So it has incorporated these theories of systems engineering, management, innovation and design, technology, logistics, ecology and behavioral science. Because gradually we are entering into a phenomenon, into an era where environmental factors has to be taken into consideration, and all over the world most of the countries, they are enacting the laws through their parliament environmental legislation act. So those things has to be complied with by the organization. So equipment has to be designed and operate accordingly. So ecology and behavioral science has came into picture lately in end 70s or early 80s. But these theories of systems engineering, management of innovation and design, technology, logistics, that has gradually developed from the mid 70s onwards and 80s. Some of the techniques we are yet to adopt in India, but European countries, Japan and America, they have adopted many of these theories way back in 70s and 80s. Now what is the technology? This concept of this word technology has been derived from a Greek word terrain. To meaning of that is to look after, to take care of, to guard over the equipments, that we call the terrain. From terrain we have developed an English terminology, that is the technology, to take care of the equipments, to take care of the assets. So what it deals with, design to discard, this theory has been incorporated in the technology from the systems engineering viewpoint. So here we consider the design, manufacturing, installation, commissioning, maintenance, replacement and salvage. So that we call the design to discard. That means cradle to death of the equipment, that we considered here, and we gave the name the technology, borrowed from the Greek word terrain. It is actually a combination of managerial, financial engineering and other practices applied to physical assets for optimum life cycle cost. We also introduced a new terminology that we call the life cycle cost, LCC, because we are considering all the aspects from design to discard in this theory. So when the cost has to be calculated, that has to be from design to discard, and that we call the life cycle costing. So LCC, a new term, and with the respect to the development of the technology. Life cycle cost, how we calculate it? Life cycle cost is the acquisition cost plus operations and support cost plus failure cost and minus net salvage value, that we call the life cycle cost. Obviously how much we are spending for acquiring that equipment or assets, for operations and support cost, for its life period there will be operations and support cost. Then we have a failure cost also, that is the maintenance cost, minus the salvage value, net salvage value. That means end of the, if the equipment life of the equipment is 10 years or 15 years, at the end of the life period, what is the value? That we call the salvage value. So accordingly, life cycle profit for the equipment, that also can be calculated in that way, that revenue generated minus life cycle cost. Terro technology has also incorporated another aspect that we call the design audit, because Terro technology considered the equipments from design to discard. So design audit is also very important aspects of that. So design audit, what they want to do, critical scrutiny of designs by operating and maintenance engineers, because ultimately it has to be operated by the operations engineers in the industries, and it has to be maintained by the maintenance engineers. So the availability and maintainability, that these two aspects of the equipment or maintenance management has to be taken care of by these two sets of peoples. So we should constitute a committee or team taking people from these two areas, and they should do the design audits. What they will do to ensure the reliability and maintainability of the equipment, to suggest any design modification. These two tasks they will do. It is a total maintenance systems. So Terro technology concept can be applied to any physical assets irrespective of size and complexity. Unfortunately, this term Terro technology we have not practiced much in India, but Europe and Japan, they have taken lots of interest to apply this concept of Terro technology in their plant and equipment design. So what are the factors affecting the maintenance strategy? This diagram shows there are the inputs. What are these inputs? Inputs and output. Output we have not mentioned what are the things, but what are the inputs for the maintenance, deciding the maintenance strategy, or we can say these inputs are the different parameters or variables that affects the maintenance strategy. So these are these internal resource level, maintenance objectives, statutory inspections, safety requirements, contract resource policy, because many of the organization now they are going for the AMC, annual maintenance contract. So if we get for the annual maintenance contract, in that case what will be the contract resource policy, that has to be decided. Plant condition and age, because maintenance requirement that will vary with the age of the equipment and other operating conditions of the equipment. Long and short term production requirement, and of course the company or the organization, they should have the long term maintenance strategy, and accordingly depending upon these variables they should decide that what kind of strategy, long term and short term strategy, they should follow in their organizations. There cannot be the ready-made answer for that, because all these variables inputs that varies from organization to organization. One tire manufacturing organization and one nuclear power plant, these are the two different aspects. They operate in the two different conditions. So their requirements, all other variables, safety requirements, those are the different. And with the variation of the organization, variation of the production capacity, production type of the equipment, many of the variables that will get changed. So there cannot be the ready-made answer for this, but these are the input. The peoples in that organizations, those who are the helm of affairs of the maintenance, production, operations, productions, they design, they should sit together and find out a solution for the equipment, for the organizations. There is one important curve, we call it as a bathtub curve, because it looks like a bathtub. This curve that shows the two things over a period of time. X-axis represents the time and Y-axis represents the failure rate. What is the failure rate of the equipments over a period of time? Actually it has been taken from the human life. When a child is born, say at least up to 6-7 years, frequently the child falls ill. That we call the failure rate. So if we look at the early period, early life, failure rate, initially it is high, gradually it comes down. That is in the left hand side of this figure. And then middle life failure, so failure rate more or less it remains constant. So we can say that for a child up to 8 years, it is a early life where failure rate initially it was very high, gradually it comes down, and from that up to say 60-65, it is a constant failure rate, which we call the middle life failure, where failure rate is low and more or less stable. That's why we call it as a constant failure rate. And after that, say 65 and 70, for a human life, failure rate again starts increasing. That we call old age and gradually die. Same thing happens with the equipment. Any equipment at the beginning, for few months, even if you purchase a motor car, for few months its performance and failure rate will be high, and gradually it will reduce and it comes to a standard time, standard failure rate, constant, what we call the constant failure rate. So our maintenance management, that considered more at the normal operating period, where we calculate, where we have the constant failure rate, we calculate the reliability calculation, all our maintenance activities that is concentrated in this period, which we termed in this figure as a middle life failure or normal operating period. Maintenance management purpose is to extend this middle life or normal operating period. How long we can increase through our maintenance management activities, we try to increase this period, and ultimately one day this equipment or component is going to fail. So this is a very important curve which we have borrowed from the human life and applied in the plant and equipment or components of any product. So what are the various types of maintenance systems? Emergency and breakdown maintenance, planned maintenance, preventive maintenance, running maintenance, shutdown maintenance, time-based preventive maintenance. This time-based preventive maintenance, it is at the third stage of the bathtub curve. That means third stage means that where the old age has already, the equipment is the old age period. That is, the constant failure rate is over and gradually failure rate is increasing. The whole, at this stage, whole purpose is that how long we can use this equipment through modification, through design changes, through preventive maintenance. That we call this third stage of this, and then replacement of the equipment, replacement of the components. We can have also the corrective maintenance of the components. We can have also the corrective maintenance to restore to original condition, that is called the corrective maintenance. Minor repair and replacement of components, condition based maintenance, and design out maintenance. So some of the things we can study or discuss, that is the breakdown and corrective maintenance. It has 4 different steps. First is the fault detection, fault isolation, and fault elimination. Fault elimination means adjust, align, and calibrate. We can repair it, or we can remove and replace some of the components. After that, we must verify whether fault has been eliminated or not. That we call this verification that fault has been eliminated. These are the 4 steps in breakdown and corrective maintenance. Planned and preventive maintenance requirement. There are certain requirements for the planned and preventive maintenance. That means the concerned department, they should request to the maintenance department, because maintenance department in any organization, it is a separate department. Unless the required department they made a request, maintenance will not be active for the repairing or to restore that equipment. So first is the maintenance request, asset and facility register, that is a stock taking must be there, maintenance schedule, work and job specification. If possible, every time it may not be possible to specify accurately work and job specification, unless you move to the maintenance technician, they move to the spot. But in many other cases, it may be possible. Planned maintenance program, annual and weekly plan, inspection report, history cards. From that we can decide, we can find out that how many times in a year this equipment fails and what kind of failure it has, so that pre-planned action can be taken. Planned lubrication, work priority and safety. These are the requirements for the planned and preventive maintenance. Design out maintenance. Here actually we try to redesign the equipment if necessary. Due to certain design defect or design defect, equipment may fails repeatedly. In that case, we incur the cost of the maintenance. So it is a choice between cost of redesign plus reduced maintenance cost, because the whole purpose of redesign is that how to reduce the maintenance cost or how to reduce the maintenance time. So time is cost is proportional to the time. So we look at the problem from that perspective, that cost of redesign will reduce the maintenance cost. But still there will be maintenance cost, but there will be reduced maintenance cost. This is the one cost, and if we don't do, what are the cost? Recurring cost of best maintenance procedure. So it is a trade-off or the choice between the two aspects. One is that cost of redesign plus reduced maintenance cost versus recurring cost of the best maintenance procedure. This we call the design out maintenance. Of course, it has also the various steps. What are the steps? Identify the defects causing the high maintenance cost. So we must have the certain analysis, cause and effect. Through Pareto curve, we can find out these things. Look into the possible causes and causes of the defect. Identify the possible solution to eliminate the cause. Suggest the necessary modification, eliminating or reducing the effect of the defect. Compare financial benefits against investment required. Assesses the degree of risk with the new modification. Then there is the maintenance planning and control. How we plan and what controlling mechanism we would like to implement in that organization. This is to generate and maintain reliable, timely and appropriate information for decision making in maintenance. What we will do? First thing is the routine analysis, that is labor and cost. Say weekly analysis we should do. The whole purpose is that to maintain a record of everything what we are doing from the maintenance department with respect to the various equipments of various departments. Then second is that work measurement. That means how much time we have spent or how much time we should have spent and actually how much time we have spent. So work measurement, work loading, manpower planning. Then critical breakdown and analysis. This critical breakdown analysis means we should draw the Pareto curve. First we should have the record, past record. Past record should be converted into histogram. From the histogram we should draw the Pareto curve. So Pareto curve will definitely show that 70% of the breakdown or 70 or 80% of the breakdown is contributed by 10% of the defects of the equipments. The whole purpose is that to categorize, to classify the defects, how frequently one defect is occurs. So the defects that frequently occurred, that should be taken care of first. We have the 3 steps for this. Step 1, whether it can be eliminated. Can it be eliminated? If yes, do that. If no, go to the step. Go to the next step. Next step is step 2. Can it be simplified? If yes, do that. If no, go to the next step. Step 3. Can it be improved? If yes, do that. If no, hardly any other option. Then we have, if we have the planning and controlling, then we must have the maintenance costing and budgeting. So how will the cost and budgeting will be done? We can have the capital project, that means which we call the capital shutdown, like steel plant, power plant, any kinds of metallurgical operating plant, nuclear power plant, nuclear reactor, which will take 30 to 50 days for the capital shutdown, and yearly once has to be done. So those kind of things we call is a capital shutdown, and for that capital project allocation of the fund has to be there. Planned preventive maintenance, basically it is a time-based preventive maintenance. Workshop services, what are the costs involved? Basically the cost heads code should be there. That should be related with the wages and salaries, overhead charges, material cost, transport cost, sundry items. Cost report can be analyzed for the variances. That means what it is actual and what it was planned. Actual versus planned, that we call the variances. That means how much it is the variate from the planned cost. We can has also incorporated cost related with the terror technology, that is from design to salvage and life cycle costing concept of an assets. So these are the costing aspects, costing and budgeting aspects of the maintenance. So what are the recent trends? These are the traditional maintenance what we have discussed till now, but from 80s onwards gradually we have the 3 more maintenance systems has evolved. So those are the things. First is that condition based maintenance, CBM, reliability centers maintenance, RCM, total productive maintenance, TPM. Condition based maintenance, equipment maintained when measurement indicates an incipient failure. The condition of the machine is determined continuously or at regular intervals by monitoring certain conditions. These conditions will be related to vibration, temperature, wear and tear, performance parameters. So we should have certain mechanism to acquire this data from the equipments. So basically the name itself indicates that condition based monitoring maintenance. So we are trying to find out, or we are keeping track of various conditions related to the vibration, temperature, wear and tear and performance parameters. So we should have certain mechanism to for the data acquisition related to these things, and we can implement the CDM in there are a number of steps that are listing the identification of the plant machines, and there are various steps for that. Reliability center maintenance, development to assure the aircraft reliability. It has developed to assure the aircraft reliability, because any failure in the aircraft, the cost of failure is very high. So that's why we are very much careful about this aircraft, and it has developed, this concept has developed in the aircraft industry, how to assure the aircraft reliability. So RCM is a systematic approach for quantitatively determining the maintenance requirement of any physical assets in operating context. It is a systematic approach for quantitatively determining the maintenance requirement. Reliability center maintenance employ the system's perspective for developing and selecting maintenance design alternative based on safety, operational and economic criteria. So what are the steps in the RCM? That is reliability center maintenance. Select the most critical equipment, identify the function of the equipment, establish the performance standard, determine the type of the failure. Fifth steps is that enumerate consequences of the failure. That means from types of failure, we determine the consequences of the failure. Rank the consequences of the failure. As I mentioned already, that in the aircraft industry, the failure of the aircraft, if there is a failure of the aircraft, cost of the failure is a very high. So all these consequences of the failure, that one should analyze it and rank the consequences of the failure. Like priority, we should assign. Apply the most effective maintenance strategy and establish an overall implementation plan. And then comes the total productive maintenance. It was developed in Japan in 1971. The word total has three important features in TPM. First one is the total effectiveness, that we call this economic efficiency or profitability. Second, total PM, that is to improve the maintainability and preventive maintenance in totality. Total participation, autonomous maintenance by operators and small group activities in every department at all level. These are the three important factors of the total, this term. That means in totality, with the total participation, we want to activate the maintenance activity in such a way that ultimately economic efficiency, it gives us better economic efficiency and profitability for the organization. Basically, it tries to eliminate 6 big losses. So objective is that to eliminate or minimize these 6 big losses. What are these losses? First one is this breakdown due to equipment failure. This is one kind of time loss. Setup and adjustment. So this is another kind of things, that if equipment has to set up with the change of the object or the change of the design, then how it can be adjusted. So how we can minimize the setup and adjustment losses. Idling or minor stoppage due to abnormal operation of the machine components. Fourth one is the reduced speed of operation. Every equipment has a certain maximum speed and certain minimum speed it should operate. So what should be the optimum speed? That has to be decided by the operating conditions of the peoples in that department. Engineers, managers and technicians, they should decide in that way. So if we operate in a lower speed, that means we are losing the production. Defects in process and rework. Rework is also another kind of loss. So intuitively we take care of the quality of the production also. Reduced yield between machine startup and stable production. So how much time it take to reach at the stability of the production. So these are the 6 big losses. The TPM, total productive maintenance, it tries to either eliminate or minimize these losses. So objective is that maximum equipment effectiveness. If we reduce this loss, some of these losses, if we can reduce it, naturally effectiveness of the equipment that will increase. That we call the maximization of equipment effectiveness. Develop a system of productive maintenance for the whole life of the equipment. Involve all departments, that is design to operation, in implementing TPM. The term the total, it means that thing, that participation of everybody in that activities. So design to operation, those people should be involved in that. Actively involve everybody from top management to shop floor workers. Promote TPM through motivation management, that is autonomous small group activities. Actually Japan has developed these autonomous small group activities in a big way from the 70s onwards, in every field, whether it is a quality, maintenance, in every type of manufacturing, and they have their success is known to everybody. But when all these things has to be converted into, ultimately some calculation has to be made, quantitative calculation has to be made. What is to assess the effectiveness and efficiency of the maintenance department. So some of the things we can discuss. The first one is that maintenance productivity index. That is the output of the production divided by the cost of maintenance effort. So if cost of maintenance effort we can reduce it with the same output, our maintenance productivity index will improve. Maintenance cost index, maintenance cost into 100 divided by the capital cost. Capital cost is a one-time cost, it remains there. So maintenance cost has to be reduced. Downtime index, downtime hours divided by the total production hours. If downtime, this is one index. Then breakdown maintenance index, total hours spent in the breakdown divided by total man hours available. Then overtime hours ratio, overtime hours worked divided by total maintenance man hours. Actually we want to reduce the overtime hours. We want that everybody should work, all work should be completed properly within the working hours, and that's why overtime hours should be as little as possible. Availability, this is one of the very important measurement. Ultimately it boils down that all activities of the maintenance, and it can measure with that. Availability of the equipment should be as high as possible. So what are the components of this equation? It is uptime divided by uptime plus downtime. Uptime means working time. Now this working time, it can be called with another term we introduce, that is MTBF, mean time between failure. That means we are assuming between the two failures it is in the operating conditions. And we also introduce another term MTTR, mean time to repair. That means how much time it will take to repair in case of failure. That is the downtime. So uptime is equivalent to MTBF and downtime is equivalent to MTTR. So ultimately availability equation is MTBF divided by MTBF plus MTTR. So availability should be as high as possible. Obviously downtime, if we reduce the downtime, naturally uptime will increase, because total time remains same, say 8 hours. Or if we take the 25 working days in single shift, that means 200 working hours per month. So if downtime is reduced, uptime is automatically increased. So uptime plus downtime will remain the same, plus downtime total, but uptime increases. So as a result availability will increase. And then for the last 10-15 years we have coined another term to measure the effectiveness of the maintenance. We call it as overall equipment effectiveness, OEE. That is equal to availability into performance rate into quality rate. So here not only the availability, as a whole how this equipment is producing, performance rate, whether it is producing at the 90% rate or 80% rate, the installed capacity, then quality rate, what quality of production. So ultimately we incorporate every activities in the manufacturing or production by this term, overall equipment effectiveness, the availability in the performance rate into quality rate. So we end it here.